For instance, on this first one, just some basic review on things. Multiplication bonds are very weak. If you don't remember my goofy explanation of them before, here it is again. I compare relationships like multiplying, okay? Can't even see the bond is there. So, you know, it's like walking down the hall and you've got that boyfriend or girlfriend supposedly, but nobody knows, because that's easy to break off. Ooh, another 4 comes along, we break off with the 4s. All X and Y are left by themselves. It's kind of a shame.
It's hard, yeah.
What the heck? Why are we so dark? Just a second, let's see what we can do. Whoa. That's better. Sorry about that, I think. Yeah, that's better. Okay. So again, anytime you get into a situation like that, or I can use exponent rules. Now let's see. If I'm dividing with an exponent, how's that rule work again? What do you do with subtraction? Okay. Larger minus smaller, and you put your solution where the larger exponent is. Now I can't reduce the 3 over 5, but I can do 2 minus 1, which is 1, and since the larger exponent's in the numerator, I can put it there. Could I draw this out and write 3 times x? Sure, but that could get to be kind of ridiculous if it gets larger with an exponent, as far as I can go. Now what we're going to start seeing, though, is we're going to have plus and minus. We're going to have quantities. Notice, not only do we get to see the bond, which means it's stronger. I mean, we're talking like exchange class rings type stuff here, okay? But we also put the parentheses on as sort of another guard. So whenever you see plus or minus working here, if the parentheses aren't on there, I'd probably put them on just to remind me. If they're identical, I can whack them, okay? Whether they're right on top of each other or diagonal from each other, doesn't matter. But unless they're identical, keep putting those parentheses around to remind me of that, I can't just the x's here and call it 4/3. Okay, that doesn't work.
That's it?
They're stronger than the bond. That's it. So will they always be ready to go like that? No. Okay. Here, always just take a piece at a time. Don't try to take too big of a bite. What do those two terms have in common? X. Okay, so if I factor out an x, what's going to go in my parentheses, my quantity? X plus 5. Okay, normally if I factor something like that, I'll literally scribble out what's below it so I don't even think about trying to use it for anything. And now I'm in a situation a little bit similar to number 2. The x minus 5, there's nothing to cancel it with, so it's going to be here. What about these x's that are just hanging out on their own, though? Those have a weak bond. This x has been tossed out. It's kind of just sitting out here, so if I use my exponent rules, 2 minus 1 gets me x to the first, but where's that x going to go? The bottom, because that's where the larger exponent's at. So now, can I whack these x's and just call it 5?
Yeah, no.
No.
Bonded.
Bonded.
It's like chemistry.
It's right. They got the chemistry working here. Not going to let x, ruin that. So sometimes just thinking about these weird little things can be of some assistance. So then I get to this next one. Again, if you see plus or minus somewhere, remind yourself, there's a bond there. I cannot come and just whack those x squared. You'll drive me crazy. I'll have to start banging my head into the wall again. What can I do? Factor. So what multiplies to negative 12 but adds to negative 4? Okay, negative 6 and 2. Again, once I get that factored, we'll just get that out of here. What about the denominator? Okay, since it's a difference of squares, whatever I square to get each part, 2 and 2, but I have to have one of each sign. Because again, that cancels my middle term out and just leaves me with x squared minus 4. So that's out of there. And we got all our new identities out here. Can I whack anything?
Yes. Got
And again, whatever's left, ooh, I see the parentheses, I see the bonds. Unless they're identical, gotta leave it alone. Okay, so you're always looking for that opportunity to factor or take out a greatest common factor at the start. Like here, ooh, bond. But, okay, I can take a 5x out of here. And then again, whatever I multiply 5x by, to get each term back is what goes in here.
2x.
Okay, so 2x, because 5 times 2 is 10. X times x is x squared. And 5 times 3 is 15. Okay, so we got that out of there. Can I cancel or reduce anything?
Yeah.
Yes.
5x.
Okay, so they each have the 5. That can go away. Again, it's my exponent rules. 2 minus 1 is 1. Larger exponents in the numerator, so I have an x. And there's nothing to cancel out my 2x plus 3. So that's as far as I can go. Again, anytime you see that plus or minus bond, unless they're identical, can't do anything with it. What about 7? Anything in the numerator to factor?
Yeah.
Okay, x plus 3, x minus 3. Can't really do anything down here. You're like, well, nothing cancels. That's true. Sometimes you'll go through and you'll do your factoring, you'll do your due diligence, but you'll find out nothing cancels. So in that case, I can't do anything. All I did was factor and I'm done. Not to sound like a broken record. So on 8, I can whack the x squareds, right?
Yeah, no.
No. Bonds. Factor time. So, two numbers that multiply to positive 24 and add to negative 10.
Oh, negative 4, 6.
Negative 4, negative 6. Then a couple more that multiply to negative 12 and add to negative 4. Negative 6 and positive 2. And if I see any quantities that are alike, whack those. What's left over is the answer. So again, nothing too terribly awful working here. So, as it starts to expand a little bit, when you go to multiply, now everybody has their own way of doing things. Here's my personal opinion. Some people will say, oh, I'm just going to start canceling stuff right away, and then I'll just write what's left over, which is fine. But that can kind of get to be a slop fest because you've got stuff everywhere and you miss something. My suggestion is to multiply straight across, get it down to one fraction, and then reduce it, especially since we have calculators that can help us with stuff. So here, okay, 5 times 6 is 30. What's my exponent rule when I'm multiplying? Add. So 2 plus 3 is 5. 1 plus 2 is 3. So it's multiply the coefficients, add the exponents. 2 times 10 is 20. I've only got a single x. And y to the 4th. So, we'll kind of, once we get that part done, we'll start at the left, and we'll move our way to the right. So what's 30 over 20 going to reduce down to? 3 over 2. Basically, the zeros just go away. X, I need an exponent and where it goes.
X to the 4th of that.
Okay, x to the 4th, 5 minus 1 is 4. On top, larger exponents there.
And then y.
And then a single y, 4 minus 3 is 1. Bigger exponents down below. Okay, nothing else reduced, I'm done. So, as we start to move our way across on these, it's going to be the same type of deal. So let's just hit up this next one. Again, if I multiply right across, so I've got 16 x to the 8th, y to the 8th. Ooh, big number. 400. I've only got one x term. And always don't forget about that 1 that's on that exponent when you don't see it. So 9 and 1 would be 10. Now, if you look at 16 over 400 and you're like, yeah, right, Hardy. Remember, you've got an option with the calculator if you just hit Math Enter Enter if you're not sure. And no, I don't have to have the 1 there, but I just like doing that to remind myself that 25 doesn't go up here. Okay, if the larger number's in the denominator, that's where the number's going to end up, just like it does with the exponents. So then 8 minus 3 is 5. 10 minus 8 is 2, but that's down below. And I'm good. So here's what I want you to do for a minute. We're going to go to 11, but now the fun thing is you can't see it in here. I can see it, and the lovely people at home can see this, but you can't. Do 11, and I will momentarily here uncover this, and we can kind of make sure we're on the right track here. So if you've just been kind of working along here, jump in. Try this out and see if you hopefully come up with what will be uncovered here momentarily. Yes.
Can you fix my calculator? I keep getting crap on zeros.
Oh.
Thank you.
All right. Here comes the moment of truth. I don't hear any huge sighs, so I'm going to assume that we might be doing all right here. But that's where we're at with these. If you keep track of your exponent rules in their most basic form, we'll be good. Okay. When we get to this next section, they're going to start getting a little bigger. Now we're going to have polynomials where we're going to combine parts 1 and 2. We have to factor, but then we're still going to do some multiplying. The biggest thing with these is to not get overwhelmed. And what I mean by that is instead of looking at everything at once and going, one part at a time. So if I look at that very first part, the numerator of my first fraction, what do those two have in common? 4x. Okay, so I'll take out a 4x. What do I have left to put in my parentheses then? 1 minus x, because 4x times 1 is 4x. Negative 1 gets me the negative here, and x times x is x squared. Okay, so we're good with that. Factor the denominator of that same fraction. Multiply to negative 3 and add up to 2. Okay, 3 and negative 1. All right, we're done over there for now. I'm not going to do any canceling or reducing quite yet. Multiply to negative 6 and add to positive 1. Okay, positive 3 and negative 2. Now here's where we've got to be a little bit careful. I see right away, I've got an x plus 3 working. Okay, those can go away. I see right away that I have a 4x and a 4x. Okay, those can go away. Here's where my question lies. Are those the same? No, not yet. We're like, what do you mean not yet? Here's what I can do to fix this. anytime you have a quantity, a set of parentheses, and you need to change signs, because I notice here, this is 1, this is negative 1, this is x, this is negative x. They're opposites, basically. What I can do to make this what I want it to be is if I pull a negative out of it, if I went to the parentheses, that would change the sign on each of these, which would be the equivalent of having a negative x minus 1. Ooh, now they're kind of the same thing. So here's how I'm going to make that work on this one. When I pulled out the 4x here, if I would have pulled out a negative 4x, that would have changed the signs on both of those. Now, even though just to the bare eye, these may look different, they're not. Now, these are both positive x's. They're both negative 1s. So these now cancel, but don't forget about the negative that's still here, because once I pull the negative out, I can cancel the 4x's, but that negative's still going to be part of my answer. So I look and I'm like, okay, there's nothing left down here. And here I've got the negative and the x minus 2. You can either leave it like this, or if you want to distribute the negative through, you could. But there's going to be little things like that, okay? This is all about detail in this section. Little things like recognizing that 1 minus x and x minus 1 aren't the same right away, and kind of working through that to tweak it until I get what I want. So let's see. What if, I'm going to bounce around a little bit here. What if I bounce down to 15? And I'm like, well, that's a fraction, that isn't. It can become 1 though. Anytime I see something in one of these that isn't a fraction, I'm just going to put it over 1 to remind me this is in the numerator. This is up top. Okay, it's not in both places. It's only in one. So I look at that first fraction and I go, okay, x plus 3, I can't do anything with it. I am going to put parentheses around it though, because I got to remember it's bonded. Oh boy. Looky, looky in the denominator. It's a difference of cubes. Woohoo! Now, I was given one important clue in this though. This, a lot of the time, will end up being something that can end up canceling. So remember, when I go to factor this, difference of cubes. What do I cube to get each term here? And if you're... Okay, so 2x and 1. Okay, if at this point you still don't know your squares and cubes, squares up to at least 10, cubes up to at least 6, that's something you've got to get in your brain. Because now I look at this and say, okay, 2x and 1. So this is 2x, and since it's minus in the middle, okay, it'll be 2x minus 1. And then to get this side, just kind of a review reminder, you square your first term. So I square the 2 and the x, which would give me 4x squared. You change the sign in the middle, which becomes plus. You multiply your two individual terms together. So 2x times 1 is 2x. And then you square your last term. 1 squared is 1. Huh, what a coincidence. Because now that I've factored my difference of cubes, those are the same and can wipe out. And I was smart enough to remember to put my parentheses there because, oh yeah, unless they're identical, I can't do anything else. And that'll happen a lot on these, where you'll get into one and then you'll be like, oh, that's what that ends up being. You can kind of play with it that way. But it's one of those where, you know, straight up factoring, just taking out a greatest common factor, difference, you know, sum of cubes, those type of things can get to be kind of a headache otherwise. So then finally, as we keep to expand here, one thing, oh, that's supposed to be a multiplication dot, and something funky happened in my Word document. Sort of like on 14, this is supposed to be a division sign, all of a sudden it became a funky oval. I'm not quite sure what the deal is. And this one, where I got that funky looking oval, it's kind of weird. So once we get into this, okay, when we divide, we're going to flip the second fraction. And yes, it needs to be the second one. It's like when you're multiplying by a fraction. We always say if you're dividing by a fraction, you can multiply by its reciprocal. That's actually what we're doing here. So before I ever start factoring or doing anything fancy, I'm going to rewrite this right away so I don't forget. I'm going to turn it into multiply, and I'm going to flip the second fraction over. And now it'll work just like the ones we were doing in part 3, but you've got to remember to flip it. So once I get that rewritten, now I can dive in and actually start doing something. Can't do anything to the numerator of the first fraction. Can I do anything to the denominator, though? Okay, I can take a 3 out of those. And then I've got x minus 4, because 3 times x is 3x. 3 times negative 4 is negative 12. And it looks like that top is factorable. We're looking to multiply to 8 and add to negative 6. Negative 4 and negative 2. And then one last time here. What am I going to do? Take an x out. And then I have x, because x times x is x squared, minus 2, because x times negative 2 is negative 2x. Now I'm fully factored. Now I can go start looking for things to wipe out. Well, it's pretty obvious that the x minus 4s, okay, they're identical. The x minus 2s, they're identical. Now lies the question. Can I whack the x's? Let me ask a slightly different way. Do you see a bond? No. If you can't see the bond, it's weak enough that you can whack it. So, I can even blast those x's. You're like, but there's a 5 there. Right, but again, weak bond, anything similar is going to come in and just take it. So you're like, I'm all the way down to 5 over 3 out of all that? Yes. Okay. The only time you're restricted from zapping something is if there's that plus or minus bond there. Otherwise, jump right in and swipe it.
Can you do 14 on the other side? Really fast?
Sure. All right, back we go for a second. 14. All right, let's factor this. So multiply to negative 6 and add to positive 1, it'd be positive 3 and negative 2. I can take a 2 out of there. And here, multiply to 12 and add to 7, it'd be 3 and 4. So let's see what we can do here. X plus 4s, x plus 3s. Weak bond, I can whack the 2s. But here, I've got that minus bond. Don't try to blast that x with x squared. It won't work. All right. So that's what we're kind of dealing with. And the only difference, again, between what's going on here in part 3 and what's going on over here in part 4 is that when you see that division sign, we've got to flip the second fraction. Now let's say we're doing 14. No, let's have even more fun than that. Let's do 13.
Oh, sad.
Remember, that second thing there, even though it's not a fraction, technically is. It's something that's over 1. So before I do anything else, flip that second one over. Then I go into factoring mode. And some of you are like, uh-oh. That's right. On 13, that very first one, it's mental math or it's slide and divide.
Mental math.
Okay, and you can do that. Okay, if we're going to do some slide and divide, I'm going to do a little side work here. So if I have 6x squared plus 7x minus 3, just kind of as a review, slide that 6 on down to the end. When we slide it down there, we end up multiplying it. So now I need to figure out, okay, do it just like a diamond, but this is the part that some of you tend to forget. Keep telling yourself this is slide and divide. A lot of you remember the slide part and then factor it, and then you want to put it back in that way, but that's not it. That 6 has to be put back in, okay, to divide. Additionally, normally if this reduces to a whole number, then I just roll with it. But in this case, it doesn't. And all the time we slide it back to the front. But you have to have your fraction reduced first. So what's 2/6 in its simplest form? 1/3. What about 9/6? 3/2. Once I've reduced the fraction, if it's still in a fractional state, then I can swing it back to the front. Then I can swing it back to the front, and I'm legit. That's actually the factored form.
Legit. Still have number 6.
That's true.
That was a lot of work.
It can be on some of these. Some of these will go really quick, and if you have to slide and divide a couple of times, it might take a little bit. So I look and I go, okay, take out an x, and what am I left with? Well, let's, yep, x times 2x would get me 2x squared. X times 3 would get me 3x. And now I can go into canceling mode. But here's why this one's important. I can cancel diagonally. I can cancel top to bottom. You cannot cancel side to side. I can't cancel this x with this x squared.
No.
Yes. So
Combine them.
we're going to combine. We're going to multiply here, which ends up being 6x to the third. And that's as far as I can go. Oops, get that up a little bit. So cross canceling's okay, top to bottom's okay, not side to side. Not. All right, last one. 15. You're like, oh crap, multiply and divide. Okay, whoa. I would suggest, again, anytime you get a divide, rewrite it first. Okay, the first one's multiply, so nothing's going to change. But this last one being division,
Flip it.
flip it. Here's one nice thing about 15. I only got one little piece that needs to be factored. So, (9x squared minus 25). What's it going to look like? All right. 3x times 3x gets me to 9x squared. 5 and 5 gets me to 25. And it's plus minus.
Got him.
Once I get here, let the canceling fun begin. Goodbye x plus 5. Goodbye 3x minus 5. We have x over 3x plus 5. So then I'll just whack those. It'll be like 1 over 8, right?
No.
No. Ooh, with authority. That's what I'm saying. Okay?
God.
And that's set.
This is easy.
Good.
I do it homework tonight. Yeah.
Okay, so here's how the homework works.
There's a lot.
No,
Oh, why can't we ever make a worksheet?
we do sometimes.
All I want is worksheets.
Well, I'll tell you. Here's what you can do.
You can flash copy the work page.
No, if you don't want to have to deal with taking a book or something with you, I don't have my book with me now. But if you have it,
Take a picture of it.
well, you could do that. Or,
Write them all down.
yes, or you could just take a minute, write them all down, not have to take the book with you. I know. Amazing, amazing
Write
thoughts.
down all the words.
Oh, mercy.
Oh, that is so much. I got time for that.